Yes, go ahead.
Welcome, everybody. Welcome to this session 9J, if I'm right. So it's all about nature-based solutions to mitigate hydrometeorological risk. So if that's not what you were looking for, then you still have a couple of seconds to switch the session, because if you stay here, it's going to be so interesting that you will be captivated into it. And once you've started listening to it, then you're in for 1.5 hours. So better leave now or stay with us for this exciting session. Today on stage, we have three speakers. We have Marc Barra, Silvana Di Sabatino, and James Murray. So hi, Marc.
Hello.
Hi, Silvana.
Hello.
Hi, James.
Hi there.
So we will be kicking off in just a second. I'm just leaving, I'm French, so I have to leave a bit of French time. There's 1-2 minutes before we kick off, just for everyone to settle. You can use the chat, you can raise your hand. Both options are possible. I'd be very happy to take your questions to our experts, and then to be your voice in that session and to share it with them, so that you get this kind of interaction we're all looking for. And that being said, you'll see that we have some snack content for you to check after the conference if you're interested to follow on their content. We have some infographics about each of the guests, each of the topics. We have some videos, we have some podcast episodes. So it's a bit of a package, but what you won't be taking from that session is this element of the live, and I'm playing a bit on the fear of missing out, which is absolutely right in that case. So the 2 minutes of courtesy time is over. I propose you to switch to our very first topic. And to introduce that very first topic, we have a short video, which I'll start sharing in just a second. Here we go. So welcome to the session. We are on.
Are we experiencing a shift of paradigm? I know the question is overused, but
some hydraulic engineers are turning back actually to a century of hygienic ideology, where nature was sent outside the city, urban rivers were channeled and buried and sanitized.
Marc Barra is an urban ecologist specializing in nature-based solutions at Paris Agency for Biodiversity, in charge of the H2020 Regreen project. That is not a straight and easy line, though. First, you'll have to prove the science.
Regreen is an H2020 program on nature-based solution in urban areas. It's a project involving almost 20 partners from Europe, from China, to show that nature-based solution can solve many urban issues.
This actually happens on two levels. First, proving that nature-based solutions can one-to-one deliver the same results as grey infrastructure and hard engineering. And second, quantifying nature-based solutions' welcome side effects, ranging from climate change adaptation to biodiversity recovery through increased quality of life in cities. To do so, Regreen monitors 6 urban living labs, or ULLs.
Urban living lab is usually a city or a province where all these work packages apply, and where we do demonstrators as well of the project.
The Paris ULL focuses on two main challenges. First, reducing urban heat.
In 2003, during the heat waves, there's been between 8 and 10 degrees difference between Paris and the countryside.
Second, water management.
There will be an increase in flooding and in runoff, as well as shortage in water supply in other parts of the years.
But above all, as all the challenges are deeply interlinked, evaluating nature-based solutions calls for a holistic approach. For instance,
when you restore a river, you don't just manage the water and the runoff, you also provide a new recreation area for the people. You also provide habitats for biodiversity.
Sure, that doesn't come for free, as you need space and well-thought environmental engineering. But in light of the benefits it unlocks, can we still afford to do otherwise?
After that introduction, I'll leave you the floor, Marc, with this opening question. What would be your elevator 40-second pitch to Regreen?
Hello everyone, good afternoon. Thank you very much, Antoine. Well, I presented Regreen in this video. Thanks, Antoine, for the video, which is about nature-based solution in urban areas. Well, in Regreen at the moment, there's a lot going on, and while what I like in this project, and I didn't say in the video, is that there are different aspects of addressing nature-based solution. There's a work package on awareness and experience about children and youth experience of nature-based solution. There are researchers working on modeling and quantifying the benefits of nature-based solution. There are other work package working on the governance and how we translate those nature-based solutions into urban planning, for example. And then another work package on business incubation and how we create jobs with NBS. So that's a lot going on in all the different aspects of on NBS, and that's what is interesting with this project.
The floor is yours.
Okay.
Sorry.
Sorry, I will carry on with the presentation. So just the time to share my screen. Are you able to see it?
Yep.
Probably I should full. Okay, now that should be good. Okay, and I just wanted to highlight some of the projects that are, of course, related with water management, with flood management, because it's one of the biggest issue actually that we have to deal with. So in the part of Regreen, some researchers helped us to prepare this map. Which is some of the NBS project, actually 36 NBS project in the Paris region. And what you can notice is that most of them are actually related to water management, flood and runoff mitigation, for example, but also urban river restoration. And that show that it's a very big issue in our province. So what I wanted to do is to go through some of these projects and maybe give you some example at the city scale, at the neighborhood scale, and at the building scale, showing what we can do at these different levels. So the first project I had in mind is the one we call our flagship project of NBS in the Paris region. It's been done by a syndicate in the north of Paris, and it's called the flood expansion area of the Vinois in Gonesse City. We've been there in September with the Regreen team for a field trip, and that's actually an urban wetland that combines in one way flood risk reduction, but also ecosystem improvement and improved living conditions for citizens. So what you see in the picture, you have to imagine that years ago, this place used to be flooded regularly and the houses around were flooded regularly. And now it's a 12-hectare restored floodplain with a capacity of more than 50,000 cubic meters of water, but also a new ecosystem for the people. So it illustrates the multifunctionality actually of nature-based solution. So we are currently doing with some partners a monitoring of this place in order to assess the biodiversity, different kind of biodiversity, to be able to show the efficiency of this kind of nature-based solution on nature and biodiversity. There's another flagship project that has been done also by the same syndicate, which is this river reopening project. And actually in the Paris region, there are more than 50 projects of river restoration that have been implemented. This one is in Sarcelles in the north of Paris, and it's a former channeled and buried river that was beneath the road that you can see in the picture. And it's been turned in a natural river on almost 1 kilometer. And here again, the benefits that we see after this project are, of course, the improvement of the water management, runoff management and water quality, but also the appropriation from the local people from every age that use the place, and it's a recreational place for citizens as well as a place for biodiversity. If we look at the neighborhood scale, actually, there's a lot going on at the moment as well. I think that mentality are changing regarding water management and the use of green infrastructure alternative to stormwater management. And most of these NBS projects at the neighborhood scale are made possible in France because of the incentives of the water agencies. We are very lucky that the water agencies that long ago used to finance gray infrastructure now finance green infrastructure. And all that you can see in the picture, and of course, all these solutions are widespread now, I think, in every countries. These incentives target biosways, restoration of ponds, restoration of rain gardens, vegetated ditches, small urban wetlands, and even depaving. So that's really encouraging, and that's what has been done in these two projects where the municipality in the north of Paris turned former green spaces into gray infrastructure such as water concrete tanks and pipes into green space. And the project that you see here have been designed to manage what we call open air rainwater. It's actually new floodable green space that receive the runoff from the street, from the surrounding, and from the buildings. And here again, the interest is the multifunctionality. When there are heavy rains, like we see in the photo below, there are still pedestrian paths that still allow walkers to move from one place through the garden when it's submerged. So there's also a social role of this NBS. And finally, NBS can be also useful at the building scale. And for example, green roof. I think we talk a lot about green roof at the moment. They can be useful for water retention. That's actually what we read in literature. We wanted to get more proof about that and really assess the benefits provided by green roof. So what we did is that during 3 years in France, we carried out an ecological assessment of 36 green roofs in the Paris region. The goal was to evaluate the benefits on biodiversity, but also on ecosystem services such as rainwater retention, the cooling effect, and the carbon storage. And we tried to evaluate different kind of green roof. And one of these analyses concerned the understanding of the water storage potential by analyzing the substrate. And our results are quite interesting. Actually, what we can say is that there are strong variations regarding water retention capacity by green roof. They are all different, actually. And for example, in our sample of green roof, the least absorbent roof retain only 6 liters per square meter of the roof with a substrate depth of 3 centimeters, while the most absorbent is able to retain 500 liters of water with a substrate of 1 meter. So it depends of the depth of the substrate, of the quality of the substrate, of the vegetation. So in order to do some more analysis, we use a model integrating more variables such as vegetation, climate, and the model confirmed that out of our 36 green roof, there are 34 that are able to absorb what we call a seasonal rainfall. It's 8 millimeters of water in 24 hours, a classic rain, we could say that. But when it comes to a 10-year average rain, only 13 green roof out of the 36 can absorb it. So It's the kind of results that can be useful, for example, for local authorities in their climate change strategies, helping to anticipate, for example, the rainwater management needs. And that's one thing that we are very interesting about, is how do we design the nature-based solution in order to provide some of one ecosystem services linked to the climate strategy. And last but not least, the latest study that we're working on in Regreen is a study about the potential for depaving. And I believe that there's what we could call an unknown potential of sealed and impervious surface in cities where green infrastructure can replace gray infrastructure. So we recently worked on a tool in the city of Aulnay-sous-Bois in the north of Paris, on a tool that can map the most vulnerable areas of the city regarding three challenges: the biodiversity, climate change, and health and well-being of population. While we did these scenarios, then we look at every impervious surface in the city that could be depaved or that could be renatured to implement a nature-based solution. So for example, if I show you one scenario on health and well-being, which is one of the challenge, we use actually 5 criteria, including, for example, air pollution, noise, and green space scarcity, for example. This allows us to do this first map of the vulnerable areas, the one that are in red. And then when we isolate those vulnerable areas, we look inside where are the impervious surfaces, the sealed surfaces. For example, oversized car parks, schools, building yards, areas with asphalt or unused public spaces. And then we try to calculate it. For example, here, there's a potential of more than 100 locations. It's almost 200 hectares of paved places. That could be, of course, we cannot renature everywhere, but that could be renature and improve the health and well-being of the population. So we did that for all the scenarios. And then we will try to extend this methodology to the whole Paris region. But the next step is to help the city to set up relevant scenarios of restoration and to identify in which place what should we renature. So, for example, here we use the former map of the historical rivers that are channeled also in the city. We overlap it with our tool, and so we identify some place where the river here, for example, could be renature. So that will be the next big challenge. And as an agency for biodiversity, we are also really keen that the restoration process takes into account biodiversity and ecological function. So we hope that this tool and that this work can feed municipality strategies and can be applied in urbanism documents and urban planning documents. And that was my last example. So thank you for your time. And if you have questions, of course, I would be happy to answer it.
Well, thanks a lot, Mark. I think that was really fascinating. If, as you just said very rightly, if you have questions, use the chat, whether you're on the event platform on YouTube or on Zoom, we will collect it. And I have a bunch of questions for you, but we'll keep that for our discussion at the end. Let's move to our second expert for today, which is Silvana Di Sabatino. Welcome, Silvana.
Hello.
Same process then for Mark. We will open with a small and short and hopefully straight to the point video, and then the floor is yours. So here we go for the video.
Can nature-based solutions replace hard-engineered ones? Sure, ecological engineering has a wealth of welcome side effects ranging from enhanced biodiversity up to better overall health for people surrounded again by nature through mitigating climate change or environmental risks. But does it work?
The idea in Operandum is to really construct the proof of the efficacy of nature-based solutions to mitigate hydro-meteorological risks.
Silvana Di Sabatino is a professor of atmospheric physics at the University of Bologna and coordinator of the Operandum project. Therefore, Silvana's project team leverages 10 open-air laboratories with 26 partners across 14 countries.
Open-air laboratory is, in a way, an evolution of the living lab, but really customized for hydrometeorological risk.
Each of these labs is tailored to represent a specific problem, like a landslide in Austria, desertification in China, or flood risk in Finland. It is then equipped with continuous monitoring to measure the impact and results of the nature-based solutions tested and evaluate them over time. But how do those solutions look like?
We are testing the introduction of seagrass with deep root within the existing embankment from the Panaro River, that is one of the affluents of the Po River.
This nature-based solution replaces the traditional grey approach of solidifying embankments with concrete. Now put yourself in the shoes of a river neighbor. Would you be concerned about this experiment?
It's multidisciplinary, so we have engineers, we have physicists, but we have also sociologists and many others, architects. Do participatory science is important, the co-creation and the social acceptance.
Another solution tested in the Italian open-air laboratory is a sand dune to act as a natural barrier between sea and land. It dissipates the wave's energy, protects the land from water intrusions, and diminishes the coast stress.
We have a patent already filed where we construct this dune also with the sensors and the vegetation.
Indeed, the project also aims at enabling the market uptake of nature-based solutions, which may involve business plans and replication packages. And once the science is proven, won't additional benefits make for an easy sell anyways?
And after that short introduction, I have a leading question for you as well, Silvana, which would be similar to Mark. What would be your 40-second elevator pitch for Operandum?
Well, let's say that we are trying our best to push the role of nature-based solutions because, as you rightly mentioned, so thank you for the video, for picking interesting questions, is that our challenge is to prove that we can use alternative solutions for risks associated to climate change. So this is an extra challenge that we have. As Mark was saying earlier, of course, if we restore the urban environment with nature, we can, of course, prevent from flooding. Here, this is in our case, Operandum looks extra urban environments, so coastal areas, mountain areas, plains. So there, those risks are really major, and so the role that the MBS have to have is really challenging. I will try to say something more, and if you allow me, I will share a short presentation where I will try to say a bit more about the project and where to find the results that I hope may be useful. So I will try to share my screen.
The floor is yours.
Thank you. Okay. Okay, I don't know if you can see.
It's working. Perfect.
Working?
Yep.
Okay, thank you. So just a few words about the Operandum. As I mentioned, Operandum stands for Open Air Laboratories for Nature-Based Solutions to Manage Hydrometeorological Risks. So the idea is that and the motivating factor is climate change that trigger extreme weather in many places in the world. So to recall flooding, but also storm surge, but also droughts. So these are just examples of the exacerbating events that may be associated to climate change. So Operandum try to demonstrate that the solutions based on nature can be really effective to reduce these risks, as we already said. We recall that we use the same definition of natural-based solutions as has been already used in the urban context. So the idea is to provide, in addition to a specific function, also benefits that are also economical benefits. The important part, as also Marco was mentioning, is the co-design aspect and the co-development aspect. So those solutions, differently from the typical way of doing interventions on our territories, has to be done in participation with the citizens. When we transform a territory, there should be also a co-sharing of what we are doing as a scientist, as policymakers, and so on. So the idea of the open air laboratory that, as I mentioned, is an evolution of the concept of the living labs used in the urban context, now has several aspects that are here, let's say, summarized. We have the role of natural-based in real life applications at the center, and we have a series of aspects that are the involvement of the stakeholder that helps in the co-design, but also we have intense monitoring, intense numerical modeling, and those monitoring is interpreted not only in real life, but also complemented by laboratory testing. All these elements that are embedded in a specific context of climatological data that are suited for a specific environment will be condensed together to demonstrate the role of MBS, so their benefits, and also the possibility of replicating and upscaling. Just to give a bit more an overview, you mentioned the many countries and the sites. We have 10. And our challenge and also our uniqueness as a project is to be multi-hazard. So instead of going, let's say, extensively to one hazard and have many examples, in our project, we consider different hazards and we apply the concept of all with all the elements that I mentioned for the specific hazard. So you mentioned the slides, but also we have river flooding, we have storm surge, and others. And each one will have a specific natural-based solutions or several natural-based solutions. Just to give an example, so if one consider, I picked 3 examples. One from the bottom is flooding, coastal erosion, or also, let's say, nutrient load. If one take one of those, let's say, risks, can associate a series of solutions from the bottom to the top. We have from green roofs, as has been already mentioned, for flooding, but also river embankment, also some creative solution like the role of grazing animals that can be used to also to manage lands for exceed of vegetation. Also examples of natural water retention and also similar type of solutions. But for the coastal erosion, you mentioned the dune, but also the dune itself is not sufficient for the storm surge. So this has been also coadjuvated by other measures. So at the same time, because you are at the interface between ocean and the land. So you need also to improve those solutions at the benthic layer of the ocean. So then increasing or replanting also the benthic layer by marine plants. And there are many other examples that can also be used. If we talk about nutrient load, then the management is the key. This is the example you made in Finland, that for us is an example of a mature, let's say, oil, because natural-based solutions are already there. So we don't need to reinvent when the role of natural-based solution is already been implemented into a place. So we try to learn, and then so we work in adding elements that can make the full functionality of the natural-based solution. So constructed wetland, peak flow control structures, and so on. Okay, so just this to give an example. But what is key, because we really go into an engineering side of our natural-based solution, we need a system of multi-sensors that are able to capture the multi-scale nature of the problem. Differently from the urban context, we are in large, let's say, a large scale, because if we talk about a food plain, we can talk about 100 kilometers, while our cities, if we talk about Italian cities, for example, they don't exceed 3-4 kilometers or less than kilometers in diameter. Of course, if we don't take large cities like Milan or Rome or Paris, of course, we are in another context, but the majority of our cities are small. Here, our challenge is to really show that this MBS needed to be working in synergies to be really effective. So you need then to ensure that you have a multi-scale sensor approach, but also multi-modeling approach. And we have here different examples. For instance, for the case of Austria, that where we have our landslide that is not very big, but at least we can check that through electric resistivity tomography, we can be able to monitor let's say, the sliding of the superficial land, and at the same time insert our natural-based solutions and to control how the land responds and also the time scales. If we take another example, for instance, in Greece, where there the hazard is the flooding, river flooding. So we have these differentiations about flooding can be coming from different sources. So we always specify that in our case it's river flooding. Then there was nothing, no use of natural-based solutions. So we have started implementing those solutions that is really adding extra ponds, using monitoring, and we have tried also to integrate with the numerical modeling in future scenarios, because what is important, another element, if Antoine, I can still say something, is that one of the challenge, as also Marco said, is to prove that our solutions are good solutions in future years. So our continuous maintenance of the good health of natural-based solutions has to go along with our understanding of the projections we have of climatological data for our territories. So that is an important question, and also an important demand for our natural-based solutions, that they should be functioning over time to mitigate those extremes in the future. I would like to complete my talk by, if you allow me, is just to mention what do we do in integrating what we have produced, because we sometimes are lost in front of the amount of data that we generate, and we need also some integration of also the knowledge that we have produced. So in Operandum, a great effort has been put into designing from scratch a platform that is specific for natural-based solution in a non-urban context. There are existing platforms like OPLA and others that have the demonstration of natural-based solution, but there were no existing for rural or non-urban application. Our platform, as many others, have different, let's say, connotation characteristics. It's flexible, user-centric, interoperable, open source, and interactive. So I will, of course, give you important is the role also of UNESCO in publicizing this platform, and is a suite of innovative and interactive tools where we share, store, and harmonize with a selection of metadata. So what is important also for colleagues and those working in the field is that when we have a database of whatever, reusage of all the data from other projects, or also producing new data, is important the connotation we give. So it's important that they are georeferenced, that is mentioned the role of that specific MBS to allow then the replications also by others. For others, for us, it has a web GIS integrated system, so everything can be georeferenced, as I mentioned. But at the moment, it also include data from over 300 natural-based solutions. Actually, there are at the moment over 600, but let's say that 300 has been already validated, that are where we categorize those MBS that are explicit for disaster risk reduction. But an important thing is for doing the replication and so to really reach the full potential of the MBS is also try to understand the policy that are active in different countries. So one of the challenge in Operandum, as in many other projects, maybe is try to see how can we push the regulations in accepting also in the legislation the role of MBS. So in our work also we try to document what are the barriers from the legislation point of view for the application of those solutions. Another important thing is that we can have elements of crowdsourcing, so we can add our data to the project, and also we have a recommendation that can be used by, say, managers. Another important thing is that we have, if you look at our our platform, this has been customized for a user profile. So basically, we have in place a way of communicating the information according to the typology of user. So you can look it up, I hope, and also if you're interested, help us in improving, and we can use this platform as sharing points also for other projects. And let's say that just one last slide, the user profiles that we currently have are the citizens, the scientists, the association, the policymaker, business and investors, and also we have one section that is related to news and media. We have done this release in May 2001, and so we are progressing because we are at month 38 of our project. We have a bit more than 1 year to go where we will refine. So for now, hope that I have interested you in some of the elements that we have in Operandum. I showed the platform as a hub of where we are with the scientific evidence, but also as a way of sharing our results.
Thanks a lot, Silvana. I'm sorry there was a glitch in the recording in the middle. I wasn't trying to cut you. It's just we got the same noise in our ears, but it was very interesting. So thanks a lot for sharing. Again, if you have questions on what Silvana just shared, we will have some time towards the end of the session to take the question. Like for Mark, I have taken a tons of notes. So if there's no question, don't worry. I can still ask you questions until the night today. For now, I propose you to switch to our third speaker for today, which is James Murray. I think you get used to it by now. We will start with a short video, and then I'll leave the floor to James so that he can present you a bit of what he's up. Here we go.
On the 13th of July 2002, an average monthly rainfall fell on Glasgow within just 10 hours and flooded over 500 properties. In such cases, it is tempting to look for a culprit besides nature.
The main organisations in the council and Scottish Water basically said, look, we need to be doing this better.
James Murray is the manager of the Metropolitan Glasgow Strategic Drainage Partnership for the Glasgow City Council. Hence, the MGSDP that James manages was born, but with a twist. Yes, this partnership would address flood risk reduction, but with as little steel, concrete and hard engineering as possible. This concept is called Sustainable Urban Drainage Systems, or SUDS.
It's basically around trying to manage water closer to where it lands, trying to reuse surface water if we can, but certainly trying to slow it down and control it before it gets into the formal piped drainage network.
Now, there's a terminology check to do here. We are not talking of preventing floods, but of reducing the risk. In other terms, it's about recognizing that you can't put nature in a box.
It will reduce the risk of flooding. It will help to manage flooding. It will help to reduce the impacts of flooding, but it's very dangerous to say that something will stop flooding.
A general principle to better the situation is to correct two casualties of urbanization. First, swallowing historic water courses, and second, waterproofing the city's surface. To do so, there's a wide array of options. You can create wetlands, adopt a blue-green approach, and create water storage space wherever possible. Now, do you know a better place to store water than an existing canal?
The idea that was developed was to use weather forecast data to look ahead and see when there's essentially when is there going to be a big storm likely to impact the north of Glasgow, to up to 24 hours in advance lower a long section of the canal by only up to 100 millimeters.
And this creates up to 55,000 cubic meters of additional storage capacity for surface water runoff. One common principle unites all of these options, though: keeping the water on the surface.
If we can keep water on the surface, it just slows it down and it gives it a chance to be used by vegetation. It gives it a chance to be evaporated by the sun, even in Scotland.
The more runoff waters get used, the less they are discharged to a river or a watercourse, which improves overall water quality. But that also exposes the last hurdle.
We are not as comfortable having open water around us.
And that is arguably because we've forgotten why our cities have been built around rivers centuries ago, 15 centuries in the case of Glasgow.
It's about trying to explain the overall benefits that are coming. It shouldn't just be a benefit for their community, but for the wider community.
Here's a study that may help. The University of Michigan found that it adds $4 to the local economy for every dollar spent on blue-green restorative infrastructure. So if you don't do it for nature or health, do it for the money.
So we've been scratching the surface with that video, but James, the floor is yours in just 1 minute after my traditional question. So what would be your elevator pitch to the MGSDP?
Hi, thanks, Antoine. Yeah, I guess I'm going to probably just launch straight into my presentation, but it's really, you know, all of what was in that excellent video you pulled together with snippets from our interview. It's about managing for greater benefit and finding those multiple benefits, and, you know, push to that point you made towards the end around the financial benefits. We still have challenges in quantifying those financial benefits, and some of the great work that Mark and Silvana talked about there is really helpful in that regard as well. So I'm going to crack on. I'll share my screen. Hopefully that'll work smoothly. If not, just give me a shout. But
that works
yes,
fine.
Thank you. So yeah, you've covered some of this already, Antoine, in that video clip, but I'll just go back over a little bit of it. So yeah, Metropolitan Glasgow Strategic Drainage Partnership, MGSDP, it's always been a bit of a mouthful, and we've struggled to come up with anything different. So we're kind of stuck with it now, but I have a role as the manager of the MGSDP. As the video touched on, it came about as a result of flooding back in 2002, and the key organisations involved in the drainage system really said, look, there's got to be a better way of doing this rather than pointing fingers and saying you're responsible for that bit of water and that bit of flooding. So it's a collaborative approach between a range of organisations, including the City Council and a few other councils, and SEPA and Scottish Water and Scottish Canals and other organisations. And it's about tackling primarily flood risk, but also the other elements to that. So there's water quality as well, there's economic development. So there's a whole range of things that are part of that sort of overall, sitting under that overall flood risk umbrella. And yeah, I mean, our initial approaches to doing some of this was realizing, look, you know, that there's some stuff here that we need to try and move quickly on, and we're going to be doing some of that in our traditional grey ways. So big tanks, big pumping stations, that sort of thing. Couple of images shown on the screen there. You know, looking to reduce the flood risk for properties. It's big infrastructure, it's carbon heavy, and it's very much dealing with the water once it's in the drainage system. Another example, big project we delivered in Glasgow, Shield Hall Tunnel, £100 million worth of investment. Again, it's big storage to reduce spills to the water environment, to reduce flood risk, but very much managing the water once it's in the drainage system. Just another example here, again, you know, several millions of pounds spent looking to manage with embankments and pumping stations. So again, very, very much traditional approaches. But as the MGSTP was developing, we very much came to the view that we need to be doing this differently. We can't keep building bigger pipes and managing the water once it's in there. We need to look a bit further upstream, and we need to take blue-green approaches, nature-based approaches, SUDS, sustainable drainage system approaches, to try and manage water further upstream in the catchment, in the system. So some of the projects we started doing as a result of that, things like the White Cart flooding project, this is very much a mixture of the two. So we've got some upper catchment storage reservoirs, hydro breaks holding back the water before it gets to the city. At the time when those were installed, those I believe were the biggest hydro breaks in the world. But part of that project has also got your traditional stuff, your walls along the sides of the rivers as it goes through the urban areas. In Scotland, legislation came in sort of late 2000s around new developments, and that's required sustainable drainage systems as part of new developments. So you're building a load of houses, you're building a new commercial building, a business building, then you need to have SUDS as part of that to manage your surface water. And there's some examples there on the screen. It's relatively easy to do the minimum required here. It's difficult to do it well, but things like swales and rain gardens are a key part of that process. Basins, ponds, street trees, etc., all part of the new development aspect. So when some new housing is being built, that's required, and that is being done. Right back at the Games Village as well, this was built for 2014 Commonwealth Games, which are held in Glasgow. Again, a range of measures there: basins, ponds, rain gardens, etc. So that's the new development side of things, and that's as I say, relatively easy to do if you've got the legislation, the requirement, policy in there for that to happen. And that applies to roads as well. So you're building a new road in Scotland, you have to drain the surface water via SUDs, via nature-based solutions, again, swales, basins, ponds, etc., to manage the flood risk, but also treat it. So you're managing water quality there as well. The new is the easy part. The harder bit is the retrofit to the existing urban environment, and that's trying to unpick some of the challenges that we've got around our big impermeable spaces within towns and cities, and try and find ways to deliver benefits that can be woven into that existing urban fabric. Some of the easier ways to do that is look at existing open space parks, and again, Mark Savannah talked about this, daylighting as we call it, or deculverting water courses that, you know, for various reasons were put into pipes over the development, the history of the development of the city. So we've been opening these up in a number of locations around the city just to bring the water course back to the surface, makes it a nicer place, home for biodiversity, but crucially opens up that floodplain, gives it capacity, room for the river to breathe and to live, and to reduce flood risk both upstream by allowing you to put more water down to this location, but also then downstream by holding water back in this location. Some of the other retrofit projects we've been delivering have very much, you know, expanded on that, using that open space and putting in ponds and basins. So this is managing flood risk, but it's also allowing us to enable sustainable development and regeneration to happen. So for some of these images, there's an area of new housing going to be built upstream, and that housing needs somewhere to put its surface water. So if you can take a strategic approach as a local authority, as a city, then you can say, well, we'll get some benefit in terms of existing flood risk and enabling development, which is good for the economy overall if we invest in this upfront and then allow this housing development to connect to it. It gets trickier as you're going more into the urban realm, as you're going into the city space, and you're trying to pick up areas, you know, that are small pockets of land to try and do stuff. You're also trying to fit it in around urban regeneration, which in cities can be particularly tricky around services and around contaminated ground. But some examples here in the east end of Glasgow, we've got a massive urban regeneration project that's underway. And that's putting in, again, some of these nature-based interventions, basins, swales, ponds, etc. But it is harder to do. It's more expensive to do as well. Another example here, a bit of deculverting, but this time we've taken out a lane of carriageway. This is in the east end of Glasgow. This was, again, the water course was in a pipe. So we've opened up that water course. The picture in the middle is after it's constructed. We're still looking to get more vegetation in there to make a nicer place, but it's already, you can see the impact there in terms of bringing the water to the surface, which even in places like Glasgow can help with urban cooling as our towns and cities warm up. But just provides that sort of connection to nature as well, and makes people a little bit more aware of what's happening around them. Again, part of, very close to housing, some redevelopment and regeneration here in the south side of Glasgow, and this was delivered as part of a green space improvements project for the local community. So alongside these surface water interventions and the nature-based stuff we're doing, we've also delivered new play areas. We made it a nicer place for the people, and placemaking is a key driver for a lot of what we do nowadays. School on the south side of Glasgow, big impermeable playground surface. We've put in new drainage. We've picked that up. We've picked up down pipes from the building. We've got a sports pitch that's got storage underneath it, and then the image you can see at the bottom of the screen is a new amphitheatre. So during very heavy rainfall, that will actually fill up with water and then slowly drain down over time as the storm leaves us. Now that's within the playground, so that's providing a link to education for the children at that school, so that they become very aware of drainage, flood risk, and how that needs to be managed. And it's also providing improved facilities within the school, because it was lacking from investment over a number of years. Other things we've been doing around Glasgow, highway rain gardens. So looking to put in retrofit measures that slow down the runoff using nature-based approaches, but also improve the water quality. These are particularly tricky to do in the urban environment and existing roads, because you're taking up some of the carriageway space, which takes up some of the parking space, which in residential areas can be very tricky to manage in terms of your community engagements and how you try and explain the benefits to them. But these have gone in successfully, and we've already seen benefit from these and other interventions in the area in terms of reducing flood risk. You know, a couple of storms we had over the summer. Prior to this intervention going in, we would have expected properties to flood, and they didn't. So we're already seeing benefit there. In the core city centre area of Glasgow, we've got what we call the Avenues programme. So it's about 140 million pounds worth of programme from 2018 stretching through to 2028. That's looking to again deliver a range of benefits here, focused on placemaking. But about improving active travel, but also adaptation to climate risks. So again, heat, air quality, surface water runoff. This has been quite interesting. The first one we put in was in Sauchiehall Street in Glasgow. So the top left image is the before, top right is what we thought it would look like, and the two images on the bottom are what it does look like. Took out 2 lanes of road, and now we've got 1 lane of, so there was 2 lanes of road, there was 2 lanes of parking here with a bit of bus as well, and now we've got 1 running lane and 1 lane that's for buses and loading and that sort of thing, and we've got 2 lanes now, active travel cycleway going in and out to the town city centre, and we've got some surface water management through street trees there. So very much delivering multiple benefits there in terms of active travel, but also adaptation and resilience. That again, it's pure retrofit in the urban realm, and really demonstrated to us how difficult that can be. It's expensive, going back to things like services, but also the disruption for the local community. Businesses really feel that impact during the construction phase, and it was very difficult for them. So that's learning we're building into subsequent elements of this Avenues project. Excuse me. And this image is just showing what we're looking to do in some of the other areas in the coming years. So images on the left hand side there, what it looks like now, images on the right, what we're aspiring to deliver in these locations. Finishing off on our Smart Canal project. So you touched on this in the video intro you did, but one of the things we've also been looking to do in terms of retrofit is how to use our existing assets better. Trying to get more out of them. So in the north of Glasgow, we had 5 main areas that we were looking to deliver new communities in. But because over history of the development of the city, the water courses had essentially disappeared into the sewage system, what we only had left up there was the canal. So we took a view as to let's use the canal to manage the surface water. The way this works is that we've got rainfall radar coming into the system, into the computers, doing their analysis. If there's a big enough storm coming, the length of the canal, I think it's about 15 kilometres of the canal, is lowered by only up to 100 millimetres. But that provides a huge capacity for surface water runoff to come from these development areas. So it's managing flood risk, but also enabling sustainable development to happen across the north of Glasgow. And it's been a very good project. The development is starting to come online now, but the full development of all those 5 sites won't be finished for another probably 7 to 10 years, although that's speeding up all the time. But again, taking a strategic view, working in partnership between the council, Scottish Canals and Scottish Water to get the infrastructure in there first and enable that development to happen in a planned way. People do want to come out and see this project, but unfortunately, there's really not a lot to see. It's just the canal. There's a few control boxes at the sides of the canal with various electricity gubbins and control gubbins in them. we've got a smart system where we can remotely operate it, but it's not, the canal doesn't suddenly drop by 100 millimeters, and you don't see anything really happening on the ground, but it's been a really good and successful project for us to deliver. So that's just a very quick run through some of the stuff we've been doing as part of the MGSTP as we look to transition from just a pure grey approach, traditional approach, to getting in more nature-based solutions, delivering more SUDs, because that's going to be the better way to manage water going forward, and particularly if we can manage it upstream before it gets into the piped drainage system.
Well, thanks a lot, James, for that very fascinating insight into what you're doing in Glasgow. I'll take all three of us back on the stage. So Silvana, Mark, James, we have one question already in the chat. Just before taking that question, let me just remind everyone that you get a chance to raise your questions to three very high European experts to that extent of mitigation of hydro-meteorological risk thanks to nature-based solutions. So leverage the opportunity. And we'll start with that first question, which is, what are the investment and funding challenges that you had when developing new approaches, such as the examples you've shared? And that's for all three of us, or all three of you, sorry. Who wants to start? James.
Yeah, it's interesting. As we move to nature-based approaches for managing surface water, some of our colleagues who are of a more traditional engineering background and history, and are used to managing hard surfaces and pipes and get it away, have to try and get their head around the maintenance aspect of maintaining a pipe is slightly different to maintaining vegetation on a nature-based approach. So that's been a challenge for us, certainly in Glasgow and Scotland, is getting our colleagues who are used to managing a certain type of asset to thinking about managing a different type of asset. Having said that, within councils, within local authorities, we do already manage parks and open space and green space. So it's not new to the organisation overall, but it's potentially new to the people who are tasked with doing the maintenance of a drainage system at the moment. So that's been one of the challenges. And as we get more nature-based stuff to manage, we maybe need more equipment or slightly different equipment to do that. So there's investment there to think about, and different profiles of doing that maintenance that you need to get used to. We are on that journey. I don't think we're there yet, but I think everyone's coming along somewhat faster and some more willing than others. But it is something you have to bear in mind, is that it is a slightly different approach, and some people will take time to get used to that.
Mark, Silvana, I see you nodding. Do you share that exact same experience?
Yeah, I agree with James, and well, about investment, one problem that I noticed in France, and I think it's the same everywhere, is the price of urban land. Actually, because if we look at literature and even concrete example, we see that nature-based solutions are usually cheaper than classic gray solution. But the problem is that they need more space, and that this land is expensive, and usually the investment cost for buying the land is a problem. So I think that this space should be anticipated in planning documents, and if planning documents are able to have a zonage for nature-based solution, that would be more easy to invest in nature-based solution. And there's also something that Mike said. I think that the most difficult is retrofitting and deconverting. Because actually we pay twice. We pay one to build the grey infrastructure and then to retrofit it. There was a report in France saying that a deconverting process is around between 400 and 600 euros per square meters. So that's huge, and if you want to do it all around the city, we need billions actually of euros to be able to do that. And about the management as well, in my ecologist point of view, is that yeah, of course, we notice in France that there is a management issue, as people that used to work in the water department are fighting, yeah, like with the green space department to know who should manage those places. I also think that in a biodiversity perspective, we need to have more unmanaged spaces and more wilderness in the city to reduce the cost of management. I know it's quite tricky, but for example, I've been to a thesis that worked on bioswales, and they showed that bioswales that are really extensively managed works are more efficient than the one that are mowed every week, etc. So maybe we can reduce the cost of management by accepting more wilderness.
There's a lot to pick in what you just said, but let me give the microphone to Silvana. How is it outside the city?
Yeah, exactly. I share the view of my colleagues here. I have to say that the challenge is in attracting investors really depend on where you sit. So let's say James is in a better position because he can act directly with the local authority and the system that applies those. If you are sitting as an academic at the university and you have a project, what you can do is to demonstrate and to facilitate the training of the new engineers or retraining of the typical, let's say, engineering approach to incorporate in a similar design what they have learned or in school, or to train the new generation to include engineering made with nature. I would add also that it is true that the cost is low at the first glance of MBS, but we need continuous monitoring. So through our project, we demonstrate that monitoring has to be continuous. The health of the MBS has to be also well maintained throughout. Otherwise, one could lose benefits. So there are costs that are over time, and one should, let's say, citizens, population should understand in a way through participation that over time the benefits will come also from the financial point of view. So it's really transforming the way we really approach our cities, our territories, and how we make use of our territories. And this is similar in the urban space and non-urban. I would say that the cost of all intervention is comparable. It depends how much you have to retrofit, as it was mentioned earlier, in an urban area, but also it depends how much land you need to cover if you are externally. So the key, just to answer, for the investors is really augment or improve our understanding of the role. And this is mandatory for the society as a whole. So it's not the task of an engineer, of a manager that sit in a city hall, but this is transforming and also make our territories resilient is a duty for the entire population. So there is the challenge, how we can involve more people in a new way of thinking.
We'll come back to that because it's also everywhere in my notes, but I'd like to pick what you both, or you all three said on retrofit, because you mentioned, James, that retrofit is harder than a green space, blue ocean approach. And Mark, you gave us a price on what it costs to retrofit, which leads me to that question. How do you decide that you go for a retrofit? And how do you decide that, no, that one is not amortized yet? Let's keep the gray approach for maybe 10 more years, and then we'll switch to a blue-green approach.
Certainly, in Glasgow, we've what we've done primarily leading through surface water management plans. We'll assess what damages are likely to happen from flooding We'll develop a range of interventions. We'll cost those and say, here's how much they're going to cost to deliver. Here's how much damages that is stacked on the other side. And it really does come down to a cost-benefit analysis then. Can you justify delivering interventions in this location to reduce damage? And you can try and factor into that things like, you know, the less tangible benefits, things like biodiversity or air quality or cooling. But depending as to who you're going to for your funding, they may not counting those bits. They may say, no, that's not in our calculation. We're just looking at damages versus cost, capital cost. So you have to build your case for delivery in that way. The one thing that kind of is in your favor in terms of flood risk is that it's not a one-off. So, you know, flooding can happen this year and next week and next month. So over time, you know, that builds up. So certainly we have seen on the projects that we delivered, particularly things like the White Carp, which is a huge intervention, you know, 59 million in total. We've already paid for that project a couple of times over in the damages that have been avoided from storms that have happened subsequently. Now, the challenge for pure retrofit in the urban realm is that it is very expensive. So getting that calculation to stack up is difficult. But if you can pull in other things like green infrastructure funding from somewhere or active travel funding from somewhere and try and do it as part of that overall scheme to deliver multiple benefits, then that helps you make that case. The one thing I would say is, in a congested urban realm where you've got a certain width of street and footpath space, if you're trying to get in highway rain gardens and active travel lanes, they sometimes are competing for the same space. So that can introduce a little bit of tension. But yeah, it's about trying to pull in these multiple benefits to make a case and take that to whomever you're making the case to try and get the funding. The last point I'd pick up probably on some of the stuff that Silvana was talking about there. You know, we've tended to find it's easier to get the capital funding. It's difficult to get the maintenance and long-term funding after, because it does need a pot of money somewhere for people to be able to do that maintenance and monitoring and things like that. And that's the particularly tricky part.
That's the very interesting common trait every time you have a utility or a government approach, which is CapEx is easier than OpEx. In the industrial world, you would see the opposite. But yeah, I get your point. But what you shared here is a lot of quantitative and objective parameters. And Mark, you shared that you had a third pillar on health and well-being, which might be maybe a bit more difficult or a bit more fuzzy to quantify in terms of monetary impact. And something which ignites all of you is that in all your picture, there were people in green spaces, and you talked a lot about social acceptance. How can you quantify that part? People wanting green space, people wanting to do better and to see their cities improving, is it, or their rural areas improving? Is it something which you take into a financial calculation, or is it nonsense to put financial and social acceptance in the same sentence?
Well, it's very difficult. I think that we would lose time to try to put that into a financial indicator. And there are some methods that exist to compare the cost benefits in a monetary approach, but I think that's been done during the past, and that's not very useful. But actually, we can use some quantitative indicators to monitor health and well-being issue. For example, in the method I presented about depaving, decoverting, we used the green space scarcity in the city. For example, that the WHO says that below 10 square meters of green space per inhabitant, it's too low. So that can be, for example, one indicator. But also we try to assess the vulnerability of people that are affected by urban heat island in places of the city that we know that every time there's a urban heat, they are affected. That could be also an indicator. So, well, that could be a way to assess it. And about your question about where should we retrofit at first. Where are the priority? I think it's quite obvious for the city. For example, in France, we see that there is a big movement about schoolyards, because that's where the children are. That's where we can have a great impact on health and weight and well-being without even measuring it, even if we could do it. But that's places that are obvious for retrofitting. So I think that's the way it's happening now. We just look at priority places for retrofitting. And when I talk about NBS, I often talk about no regret measures. It cannot be worse if we green a place than before when there was concrete. So it's actually the policy that is going on in France about NBS. It's not really planned. It's a no regret measures that are implemented.
If I may add something, just another perspective is you talked about how we measure well-being. I'm a physicist, so I will give you an original, let's say, response. When we measure, it's also important that in addition to quantitative measurement, we add the qualitative assessment, so qualitative measurement, let's say. And this, although not measurable, not repeatable, as it typically is a quantitative measure, you could still give associate some numbers. In fact, what I mentioned in my, let's say, my presentation, that the contribution from social science, a social scientist that have a different way of assessing elements that sometimes are intangible. So how we measure well-being, it means being happier, not necessarily associated to a pathology or to some identified, let's say, illness. So those elements can be added into our indicators, because we work, when we talk about NBS, we don't need only engineers, but we need a large variety of specialists that can give a contribution also to connotate those elements that are not quantitative. And as an academic that are in science, in hard science, I have learned a lot through the European projects in really understanding what is the role of integrated science from also a variety of, let's say, of competencies and experts. You know, what we can get from knowledgeable expertise from different fields. So it can be done. As I said earlier, is a transformation of the way of thinking. And I add another element. Also, the culture and the political setting of where we are is really important. In our interview, in fact, Antoine, we talked of the fact that if you are in Southern Europe or you are in Scandinavian countries where, let's say, the land per person is different, the density of population is different, the way you react to the transformation is different. So in our working together, you know, in our project where we are from different countries and we share our experiences, is also important to convey to the countries where we act and live different way of perceiving our territories. And this is also part of, let's say, a cultural transformation. And in southern countries in Europe, this is new. We perceive nature differently from a Scandinavian, just because we are exposed less to, let's say, to the wilderness and to the nature. This is an important element for the future, in my view.
Talking of that difference of approach, we have a question in the chat which resonates very well with what you just said, which is, what are the challenges in applying the advanced models, methods, and analysis, simulations that are testing in living labs in practice, especially in a city that may not have
exactly.
the same capabilities and financial.
Thank you. This is one of the questions often I have been asked. Okay, one answer is that we can rely, for instance, if not models, also on low-cost sensors. Let's say that the technology now is up to the market, so that instead of having high-end, let's say, technology or models, one can also decide for, let's say, low cost, but also for models that are less sophisticated, but are, let's say, based on physical based. And the idea is to have a personnel that can, let's say, in the city council, take those graduates, the new generation that are able to pick from the literature. To have an advanced model doesn't cost much. There are open source type of models. The idea is to have a network of data, have a centralized data, because one of the challenges, if you work in the urban, but more in non-urban, is even to have access to digitalize the data. It is, of course, important that one step forward is that you digitalize the data you have, because otherwise your model can be a Ferrari, but in the end, it works like a Cinquecento, so like a small Fiat machine, so just to be in a house. So what is important then is to have accurate data. The sophistication of the model is not a problem, because we are in shared science, so this is available. But if you don't have the data you need, this is problematic. So the let's say suggestion is to verify if we have enough technology to centralize our data. More data we have, experts will run the models. They are not costly in the end.
If I may challenge that, if you allow me.
Please.
There's
I like challenges.
There's the tool itself, but you need to have the people running the tool. And you've said very rightly that when you move to nature-based solutions, you're transforming a CapEx into an OpEx. So you need people to follow your new solutions. And those people, I'm not even talking of if they are cheap or not, but do they exist? Are they available? Is it an existing science where you have people that can be actively trained, they come out of school, and that you can use directly in every city in Europe?
Okay, if I can answer, and I leave the floor to my colleagues, they both mentioned the children. We have started with our, let's say, Horizon 2020, now going into new program, in the look co-design, but also into really working with them and sharing knowledge. So even first, the children are sensibilized, and also in our programs at the university, but also in a high school, we started to introduce those solutions. So we are training the new generation at the same time. And as academics, this is our role. But at the same time, through the projects that we are running, we have also elements of empowering citizens and also capacity building. And capacity building include also the training around those ideas that are cutting edge, let's say, science or integrated science that we are producing through our projects.
Do you have another take, Mark? James? If not, I have questions for you.
I would just, I think I agree with Savannah to work with kids, children, young people, but also universities, education establishments. One or two, I mean, in Glasgow, we've not been good at getting funding for monitoring, and that's a gap in our knowledge, undoubtedly. But you know, one or two of our latest projects have come from part of the funding have come from an organization that has required there to be some monitoring. So that's useful as well. You know, if a requirement of your capital funding is that you do some monitoring, that makes you do it. But we definitely need more data. And yes, using education establishment, universities is going to be a key part of developing that knowledge base and data set.
While you're at it, James, I have a question in the chat for you. It's a technical question. You have a significant amount of rainfall throughout the year in Glasgow. Are subsurface water level and soil types being considered when planning for NBS for flood management?
Yeah, absolutely. We'll do a full SI on wherever we're proposing to put an intervention, and that will then inform the subsequent design. I touched on, I mentioned it once or twice around contamination, and it's an issue that has come up on a number of projects in Glasgow with our historic legacy of industrial land uses in parts of the city. When you then go to deliver something which involves digging into the ground, you can often find something nasty in there. So yeah, the SI is a key part of that. In the west of Scotland, we've generally got clay type soils. So it's very unusual for our SUDs, our nature-based solutions, to design for infiltration. We just generally don't get it to work well in Glasgow in the west of Scotland. So we're not generally looking to do infiltration as part of our scheme. And most of our SUDs will actually be lined, partly because of water table levels, partly because of risks of contamination and mobilizing contaminants and bringing them into the drainage system. So yes, we do look at water tables, contamination, soil profiles, etc., and that's fed into the design.
And I think if I recall right in your presentation, Silvana, you had also examples of how you can measure those in the soil. So I think we have kind of a stereo answer to that question. I have a question which is almost a swear word. We've been talking of nature-based solutions. There's nature in the name. I think I've raised the question to some of you in our podcast deep dive. Is it a hippie science? And I'm not coming back to that question. But in every of your project, at least in the Regreen and Operandum project, there's this aspect of turning it into a business model. I think in Regreen, you have some startups that you're incubating. I know that in Operandum, you have some patents which are filed. So how important is that step in the promotion of nature-based solutions, having the businesses around it?
Well,
Mark, Dana, want to go first?
Yeah, okay, I go first because you mentioned the patent. Of course, you mentioned this earlier, or maybe James. Everyone maybe as I mentioned that if you can show that you can work with nature, but also maintain a good economy and economic growth in the area where you are, this is a good selling point. So if you have a market, it means that you are ahead in the market in promoting those solutions that are now springing more and more. So that is also an important means of establishing new companies that may want to shift from the typical engineering, grey engineering, to nature-based solutions. I mentioned in the podcast that, for instance, in Italy, we have a large company that is Rina Consulting, that is one of the partners of the project. They are typical engineering company, one of the largest in Italy, and now they are converting part of their business towards these solutions. So we are talking about large enterprises. So this is usually, if you have this transformation from the top, you also will generate new ideas, new startups that goes into innovation around those topics.
Mark, startup exercise. You have 2 minutes to pitch the startup in your program.
Well, that will be short because I totally agree with Silvana, and I have the same feeling in France that we have in one hand this need for shifts and for transformation of existing businesses, and the people that used to work as hydraulic engineers must be trained if they are interested in green infrastructure and nature-based solution. The same for people that used to do roof waterproofing. They can also be trained to do green roof. So there's this big need for transformation. But I also noticed that we need new jobs actually on the field of what I call ecological engineering. That means people producing, for example, seeds and plants which is not horticulture. I'm not talking about horticulture, but I mean people collecting wild flowers and wild seeds in natural areas to develop it and to provide it for the city. People that are able to restore soils by introducing earthworms, by introducing bacteria, all this ecological engineering stuff, we miss it. And I have the feeling that we are still we are seeing nature-based solution as horticulture or as landscape classic practices, and we need to evolve to bring more ecology in those practices. And also, last thing about businesses, I know that big companies are actually interested in nature-based solution, but I fear that there is a kind of standardization of nature-based solution at the moment, and green roof, for example, are a great example. They all look the same everywhere. 90% of the green roof are the same in the north of France, in the south of France, and in other countries in Europe. So we also need to think how we do businesses that are consistent with the local context, in the choice of species, in the people they bring in the way they design those nature-based solutions. For me, that's not compatible with another overall market everywhere in the world that produce the same product in factories.
So I have to cut you, and I'm sorry because there would be so much more. If you were looking at my notes, I have like 30 questions which are unanswered. If you want to follow up, you who are still watching us after 1.5 hours, I've synthesized everything we've got from our 3 experts today. You can go to innovate for cities, sorry. And there you'll find the link to the various videos we've showed today. Also, every time the deep dive interview with each of our 3 guests today, and an infographic where you have the cartoon versions of the 3 of them discussing the matter we've shared today. On top of that, James, Mark, Silvana, do you have somewhere where you want to redirect people just after this conference if they want to follow on with you? Where shall they contact you at best?
MGST. On you go, Silvana.
No, sorry. To our email, to the project website, Operando in my case, and there is also a link, and they can write to me directly.
Yeah, the MGSTP is a website, mgstp.org.
And for you, Mark?
Yeah, and about the Regreen project, regreen/project.eu.
Well, it was fascinating. We are only 1 minute late, so it's okay. I'm still French, so 1 minute is good. Thanks a lot for attending that session. There are a lot of other very interesting sessions which might be starting right now. So we'll leave them the floor. And in case you enjoyed what you've seen and listened to, well, contact our speakers, and then we'll be happy to follow on with you. Thanks a lot.
Nice infographics.
Yeah, I'm very impressed.
Thank you.